All right, welcome. Today we're putting you in the captain's seat. Imagine this. You've just taken off. The gear is up, but something's wrong. You're heavy, full of fuel, and you need to get back on the ground, right now. This is about that exact moment, one of the toughest calls a pilot can make, and our goal today is to get you ready for it.
So here's our flight plan for this briefing. We're going to kick things off with a real-world story out of LAX. Then we'll dig into why this is even a problem in the first place, look at the 3 critical choices you've got, break down the rules for one of those options, jettisoning fuel, and talk about how your aircraft type completely changes the game. And we'll wrap it all up with what matters most, the captain's call.
Okay, let's start with a story that really shows you just how high the stakes are. Picture this, January 2020. What started as a totally normal takeoff from Los Angeles quickly spiraled into a major emergency, one that had consequences for years to come.
$79 million. That's how much Delta Airlines ended up paying out in a settlement. It's a huge number, and it's a powerful reminder that every decision you make up there, well, it can have some really big impacts down on the ground. Financially, environmentally, you name it.
So the plane in question was a Boeing 777, headed for Shanghai. Right after takeoff, the crew gets a compressor stall in their right engine. They do exactly what they're supposed to do. They stop the climb, and they tell ATC they need to come back to LAX. And just like that, the emergency is on.
Now this next part is really important. Listen to this exchange with air traffic control. ATC asks them straight up, do you need to hold or dump fuel? And the pilot comes back with a simple negative. Remember that. That one word becomes a huge piece of this puzzle. So even though they just said negative to dumping fuel, literally minutes later, that's exactly what they did. 15,000 pounds of jet fuel start streaming from the wings. It just goes to show you the kind of pressure these crews are under when things are changing second by second. And the fallout from this was pretty bad. See, they dumped the fuel way too low, below 3,000 feet. It didn't have a chance to turn into a mist and evaporate like it's supposed to. Instead, it came down as a liquid, right over schools and neighborhoods. Dozens of people ended up needing medical attention. And even though the FAA cleared the pilots from a regulatory standpoint, the civil lawsuit, well, we already saw how that ended. So, why is this even a thing? Why would a plane ever be too heavy to land? Well, it all boils down to a super basic concept in aircraft design. The massive difference between how much a plane can weigh when it takes off versus when it lands.
Okay, so you've got 2 key numbers for any aircraft: maximum takeoff weight, or MTOW, and maximum landing weight, MLW. And here's the kicker. The takeoff weight is almost always way higher than the landing weight. Think about it. The plane is designed to leave the ground loaded with fuel that it's going to burn off over a long flight.
And we're not talking about a small difference here. Just to give you an idea, on a big jet like a 747 flying long haul, that gap can be 200,000 pounds. That's like the weight of a blue whale. So if you have an emergency right after takeoff, suddenly you're the one who has to figure out what to do with all that extra weight before you can touch down.
All right, so let's put you back in that cockpit. You're too heavy, you're in the air, and you need to land. What do? As the pilot in command, you basically have 3 main tools in your toolbox. Each one has its pros and cons.
First up, you can just fly around. You enter a holding pattern and burn off fuel. It's clean, it's low stress on the plane, but man, it takes time. Option 2, if your plane has this system, is to jettison the fuel. That's the fastest way to shed weight, period. And your third choice is to just land the plane heavy, an overweight landing. It's immediate, but it puts a ton of stress on the landing gear and the airframe. Which one you pick totally depends on the emergency you're dealing with. Okay, so let's say you've made the call. You need to jettison fuel. You gotta understand, this is not as simple as just flipping a switch that says dump. No way. It's a very specific, highly regulated procedure, and it's all built around a really cool piece of physics.
And that principle is called fuel atomization. The whole point is to turn that liquid fuel into a super fine mist. The plane has these special nozzles that spray the fuel out, and the airflow just shreds it into tiny droplets. The idea is that this mist will totally evaporate way up in the sky, so nothing actually hits the ground.
And this brings us to the golden rule. If you remember one thing about this, remember this: altitude is everything. The guidance is super clear. You dump fuel above 5, maybe 6,000 feet. That altitude gives the fuel the time and space it needs to vaporize, which you'll remember is exactly what didn't happen back in that LAX incident.
Now, you're not doing this all on your own. You have to coordinate with air traffic control. It's mandatory. They're your partners in this. They'll find you a safe place to do it, usually over water or an unpopulated area, and clear out all the other traffic. They actually have a handy acronym for it, ASSIST, which helps them remember to acknowledge the problem, separate you from others, silence the radio, inform everyone who needs to know, support you, and give you the time you need to get it done.
All right, now for a really important point. Sometimes this whole decision is already made for you just based on the type of airplane you're flying, because, well, not all planes can even do this.
Here's the general rule. Jettison systems are almost always on the big, long-haul, wide-body jets. We're talking about your Boeing 747s, 777s, your Airbus A350s and A380s. Why? Because they're the ones with that massive gap between takeoff and landing weight we talked about. Your typical narrow-body planes like a 737 or an A320, they just don't have this system installed.
So what does that mean for you? Well, if you find yourself in a 737 with an emergency after takeoff, jettisoning fuel is completely off the table. It's not even an option. Your decision tree just got a lot simpler. You either fly around and burn it off, or if things are urgent, you brace for an overweight landing. And you know that after you're on the ground, that plane is going straight to maintenance for a full structural check.
And all of this brings us back to the single most important factor in this whole equation. And that's you, the pilot. The regs give you the rules, the plane gives you the tools, but you provide the judgment.
And this is really the key. Boeing itself says it best. Landing overweight and jettisoning fuel are both considered safe procedures. They trust that the pilot in the cockpit is the one person who can look at everything. Is it a fire, a medical issue, a flight control problem? And make the right call for that specific situation.
So let's wrap this up. Here's what you need to walk away with. 1. Both overweight landings and fuel jettisoning are safe, certified procedures. 2. Landing heavy means the plane is getting a mandatory inspection, no exceptions. 3. How bad and how urgent the emergency is, that's what drives your decision. And finally, your number one job is the safety of your plane, your passengers, and yeah, the people on the ground too.
Look, there's no magic checklist that's going to give you the perfect answer every time. There's only your training, your knowledge, and your ability to think clearly under incredible pressure. So the real question you need to carry with you isn't if you'll be ready, it's how you're going to weigh those risks when the call is yours to make. That concludes this briefing.